Okay, good morning. This is Professor David J. De Los Reyes. Okay, my topic for this session will be rectification. Okay, we go offbeat a little bit from mathematics, but this is an application of mathematics still. This will now be rectification. It is something like electronics. Okay, the problem is rectification to change alternating current to direct current. Alternating current to a direct current. Okay, I will discuss the concepts, uh, the easiest way or the simplest way I can so the layman's uh, viewer will understand it. Okay, let's proceed. The problem is something like this. How to change alternating current to direct current. The current coming from our utility line is actually alternating current, right? That is alternating current. It is sinusoidal, it is a sine wave. And the current used by our gadgets like our cell phone is actually a direct current. Direct current. Okay? Oh, it's not like that. It should be a straight line. It is direct current. Okay, straight line, but in reality, it is not really straight line. It got so many small waves like that. It depends on how big your, what you call this, filter capacitor will be. I didn't show you the filter capacitor just to simplify the figure, okay? So this is the alternating current, and we could not use or we cannot use this one in our gadgets. We must have to convert this one to a direct current for us to use it in our cell phones. Okay? So I will try to bring out the figure. We are given here a transformer. This is a primary side, secondary side, step down. It could be maybe like our cell phones. This is normally the output voltage on the DC load is actually 5 volts. So if we try to rectify what we call is an alternating current that goes to our cell phone, the one we plug in on the USB, okay? The voltage on the secondary side, the AC, maybe 12 volts maybe. Then we rectify this one, okay? We could listen this to a value 5 volts maybe, okay? But we are not on the exact value for this one at this point in time, okay? So this is the primary side, this is the secondary side. The current on the primary is alternating, and the current on the secondary, that is before the diode, is also alternating. So for us to rectify this one, to do it like this, okay, we must have to remove the negative alternation. Okay, we will remove the negative alternation. This is only half wave. I just show you half wave so it will be simple to understand. For the, what you call this, on the secondary side, what you call this, the current is still alternating, but after the diode, after this, the wave is just only one wave like this. Okay? We remove the half. Okay, the concept will be something like this. When this point here is positive and this will be negative, current will flow like this. So I will place it in the red marker. Current will flow like this. Okay, then it will go back here. That's for the positive alternation. The current that passes through the load is actually this portion here. It is this. Okay, the first one. For the negative alternation meaning because our power supply here, like in the United States, our power supply got a frequency of 60 hertz. So meaning this point here and this point changes polarity 60 times per second. So when this is plus, this will be minus, and when this is plus, the current will be this, right? For the negative alternation, when this is plus, if this is plus, this should be minus, right? So supposed to be the current will be going like this, but current cannot cannot pass through this diode when this is plus. The current in the negative alternation, it could not pass like that. It could not pass here because a diode is actually just like a switch. It will just let the alternating current pass only in one direction. That is from anode to cathode. But from cathode to anode, current cannot pass through the diode. Right? So during the negative alternation, the current is this one. It is zero. Right? Again, when this is plus again, current could pass through the diode. Okay? And the current is this one. Okay? Again, when the alternation changes, when this is plus again, current could not pass through the diode. And again, the current will be zero. Right? Zero. And again, when this is plus, okay, the current could pass through the diode and the current will be this one. Okay? So for 60 cycles, okay, 60 cycles per second, meaning when this alternates in polarity 60 times per second, we got 60 times like this, in which the second part of the alternation is actually zero. So to find the rectified value of the current, okay, to find the rectified value of the current, we cut this in half like this, then the upper portion we place it here. Okay, so we remove that one. Okay, the top portion we cut it, we put it here. So we remove this one. Okay, next one, we cut the top. Okay, we put it like this. So actually for the wave of the current, it will be something like this. Okay, it's not so smooth. Okay, so the figure, if we try to simplify, it will be something like this. It got a curve. It's not so smooth for a half wave, but for a full wave, it is much smoother. For the so-called switch mode power supply, the alternations are very negligible already. So actually for switch mode power supply, okay, that's the one being used for digital televisions, okay. We use the so-called high frequency transformer. The alternations on the secondary side is actually very smooth. So that's why for switch mode power supply we use the so-called high frequency transformer. But for now, I am only illustrating how to change alternating current to direct current. It is this. So if you try to see this on the oscilloscope, it got some fluctuations. You know, it's not a perfect straight line. It is not a perfect straight line for a half wave. But the procedure on how to rectify, it will be something like this. Okay, I will try to use this one so we can simplify it. So in simplification, it will be something like this. Okay, for the positive alternation, the current is this. Negative alternation, it is this. Positive alternation, it is this. Negative alternation, it is this. Positive alternation, it is this. So if we try to take the average of this, we cut this in half, okay? we get this one, we place it here. So we remove that one already. We cut in half, we place the top portion over here. It is something like that. Then we remove this one also. We continue it here. So actually the graph of the rectified current is something like this. You see it? It's not so smooth. Okay, but if the ripple on this, what you call this, if the frequency on the secondary side will be a very high value, these ripples will be very negligible if you try to see it on the oscilloscope. It will be something like this. And this is good for what you call this digital gadgets. Or that's the way how we rectify alternating current like this to a direct current. This is now considered direct current. But it's not so smooth. But what I am telling you just right now is actually the concept on how to change alternating current to direct current. Good morning from Los Angeles.